I want to discuss prime numbers. First, we all need to make sure we have a definition of prime numbers. So prime numbers, first off, there have to be natural numbers. So 1 to infinity. Can't have negatives or fractions. And prime numbers have exactly two distinct factors. So some examples of prime numbers are 2. It has two factors, 1 and 2. 3 is also a prime number, two factors, 1 and 3. 4 is not a prime number because it has more than two factors. It has 1, 2, and 4 as its factors, so that's more than 2. 5, prime number, two factors, 1 and 5. 6, not a prime number. 1, 2, 3, and 6 are all factors. They all divide into it. The tricky one is the number 1. 1 is not prime because it doesn't have two distinct factors. It only has one factor. So 1 is not prime. We consider 4 and 6 composite numbers. Those are numbers that have more than two distinct factors. 1 is neither prime nor composite. One skill we need to be able to do is to find the prime factorization of numbers. So that's what I want to look at. So I'm going to find the prime factorization of 36. This might be something that you remember from middle school. I'm going to make what's called a factor tree. So I'm going to figure out what numbers multiply together to give me 36. Some people might say 6 times 6. If you started with 2 times 18, you're going to get the same answer. I'm going to keep doing this method until I get only prime numbers. Well, 6 isn't a prime number. So I'm going to break 6 down into 2 times 3. 2 and 3 are prime numbers, so I need to stop. Don't keep going. I should not have 1 anywhere on my factor tree. 1's not prime, so it's not going to be part of my prime numbers. So I'm going to write this as its prime factorization. I can say 36 is equal to 2 squared, because there are 2 of them, times 3 squared. That's what a prime factorization looks like. You can check this by typing in your calculator and getting out 36. Let's try 300. So let's do the prime factorization for 300. Again, do my factor tree. Most people would say 300 is 3 times 100. 3 is prime, but 100 isn't. Let's switch it up and say 100 is 4 times 25. I need to keep going because none of these numbers are prime. 4 is 2 times 2, and 25 is 5 times 5. Now writing that as my prime factorization, I'm going to use my exponents. 2 times 2 is 2 squared, then 3, and then 5 squared. When typing this in for your homework and assessments, order isn't important. I put mine in numerical order now, but this is the same thing as 2 squared times 5 squared times 3. We can change the order. We have commutative property with multiplication. So if you don't write it in this exact order, that's fine, as long as you have a 2 squared, a 3, and a 5 squared in your answer.